Let's work on part C in this video. So suppose that we have the utility of Betty that depends on her income and on her leisure. Now, what is the optimal amount of leisure if there is no welfare program? So we can do it by using the Lagrange, right? We want to maximize a utility with respect to a constraint because we have a budget constraint, and we saw it in the previous video. That would be the budget constraint to keep in mind. So when we have no benefit from here, we would use the following budget constraint, 7200 minus 10 times L. So with this in mind, we could write our Lagrange function and work with it. So let's do so. We will have in part C the following. We will have the Lagrange function, Lagrange equal to the utility function of y to the power of 1 over 6 multiplied with L to the power of 5 over 6 plus lambda times the budget constraint, which was equal to 7200 minus 10L minus y. Now with this in mind, we will start solving with the first order how do you call that, first order conditions. First order conditions. So Lagrange derivative with respect to y must be equal to 0. Lagrange derivative with respect to L must also be equal to 0. So let's see how that works out. Now, what is the derivative of the Lagrange with respect to y? Y is our variable. We keep everything as a constant. So let's write the constant from here. That would be L to the power of 5 over 6. And we differentiate y to the power 1 over 6. That would be 1 over 6 times y to the power of 1 over 6 minus 1 is minus 5 over 6. And from here, when we differentiate this expression with respect to y, we have only the constant of minus 1 times lambda. So minus 1 times lambda equal to 0. Now this said, we do it also in the second case when we differentiate with respect to L, meaning that L is going to be the variable, y is the constant. So let's write the constant first. Y to the power of 1 over 6 times the derivative of L to the power of 5 over 6 is 5 over 6 times L to the power of 5 over 6 minus 1. That's minus 1 over 6. And over here, if we differentiate this expression with respect to L, we have only the constant of minus 10 times lambda. So minus 10 lambda equal to 0. Now that said, let's take the lambdas on one side because we will see, you know, it's going to be easier to solve. So we have L to the power of 5 over 6 times 1 over 6 times y to the power of minus 5 over 6. So y to the power of minus 5 over 6 is equal to lambda. And on the other side, on the other equation, we will have y to the power 1 over 6 multiplied with 5 over 6 multiplied with L to the power of minus 1 over 6 equals to 10 lambda. So that's equal to 10 lambda. What we can do now is to divide the second equation on both sides by 10 so that we're left only with lambda, because then we can make lambda equal to lambda and we will find a certain relationship between L and y. That's how we solve the Lagrange. So let's do so. Let's go over here below. Now, first of all, L to the power 5 over 6 times y to the power of minus 5 over 6. Well, this is a negative power, meaning that we could write it as 1 divided by y to the power 5 over 6. So we could write these two terms as one fraction. We will have L divided by y to the same power, to the power 5 over 6, multiplied with 1 over 6 equals to lambda. And over here, we will do the same. Y to the power of 1 over 6 times L to the power of negative 1 over 6. We could write it as y divided by L to the power of 1 over 6 times 5 divided by 6 divided by 10. So that's 5 over 60. That's going to be 5 divided by 60 equals to lambda. Now we did this because we want to make lambda equal to lambda, meaning we can make this equation, this expression, equal to the second one, and that's what we're going to do. So as a result, we would have L divided by y to the power of 5 over 6 times 1 over 6 equals to y divided by L to the power of 1 over 6 to the power of 1 over 6 times 5 over 60. What can we do next? Well, we can cancel out something. 6 and 60 can go away. So 6 and 60 go away and we're left with 10 over here. Now 5 and 10, we can also cancel that down. 5 divided by 10 is just going to be 1 over 2. Okay, now let's take all the variables on one side. Let's divide this one over there. So we will have L over y to the power of 5 over 6, which is L to the power 5 over 6 divided by y to the power 5 over 6 divided by y divided by L to the power 1 over 6, meaning we multiply with the inverse. So let's multiply with the inverse, which will be L to the power 1 over 6 divided by y to the power 1 over 6. Hope this makes sense. And that's equal to 1 over 2. So that's going to be equal to 1 over 2. That's what we're left with on the other side. Now, with that said, L to the power 5 over 6 times L to the power 1 over 6, well, we have the same base, we add the powers, 5 over 6 plus 1 over 6 is 6 over 6, which is 1. Over here, it's going to be the same, it's y to the power of 1, equals to 1 over 2. And if we do a cross multiplication, over here, we would have that 2 times L equals to y. Now, with that said, 2L equals to y, what we can do is to substitute it into our budget constraint, because we know our budget constraint. And our budget constraint is that y is equal to 7200 minus 10 times L. Now, instead of y, if we write 2L, right, we're substituting over here, we would have 2L equals to 7200 minus 10L. We're taking 10L on the other side, so we have 2L plus 10L, that's going to be equal to 12 times L equals to 7200. Dividing both sides by 12, we will get that the optimal number of leisure is gonna equal to 600. So leisure is gonna be 600 hours. Hope this makes sense. In the next video, we go to part D.